Hello all, welcome to BISP Self-Learning Video Tutorial Collection. My name is Amish Sharma and today I am going to show you how to simplify your Snowflake model to star schema in your framework manager. So in order to demonstrate this, I have selected a simple data model, and you can use the same techniques to uh, simplify your complex data model as well. So in this example, I am going to use a family data model which we have been using. Uh, that's called sales data model. And if you look at my data model, this is pretty simple. In order to show this graphically, I use MS Access, and you see I have put a couple of dimension over here, and all my channel, product, promotion, customer, product, all of these dimension joined with my fact table. If you look at the customer dimension carefully, the customer dimension is further normalized to country, and the cardinality is one country has got many customer, one-to-many relationship. So in Framework Manager, we are going to simplify this model and converting this model to a star schema. So there are multiple ways to do this. In today's class, we are going to talk about what are the different ways through which we can convert this Snowflake model to a star schema. So the simple way, if I graphically show you, you just join these two dimensions into a single dimension. This turns out to be a star schema from a Snowflake model. This you can also call as a denormalization. So let's see what are the different ways. The suggested ways to simplify the data modeling related concern before you pull into your framework manager. And let's be focused in a framework manager for a reporting point of view. So all the complex data modeling concern should be addressed in your physical data model. That is we call PDM. So as it is given in this example, we are denormalizing product, customer, categories, and couple of other tables into a single product table. Before I pull this metadata into my framework manager, we would like to denormalize this model in my data source itself, and therefore we call this physical data modeling. The second possible way and suggested way as well, rather than creating a physical table, we can also create a logical view. So many of your enterprise warehouse do not allow to create a physical table, and when you create a physical table, naturally the amount of administration also get enhanced. You need to rewrite your data loading process, and all ETL process has to be modified. However, by creating views, the process could be simplified. So in this example, we denormalize all this table and create a view rather than creating a table. So you got two methods: either you create physical table or you create logical view before you pull the metadata into a framework manager. Now let's see how it is done in framework manager. So if you see in my example, I've already created one view. I would delete this. I got star schema except for a customer dimension, which is further normalized to country. Now if you look at the cardinality carefully, you see the driving table is country. It means in one country there are many customers, right? But I want this model to be simplified and convert this to be this model to a star schema. One simple way is to create a physical table and join these two physical table under this one physical table. So what I did, I have already captured the SQL expression which can join these two tables and create them as one physical table. So in order to create a physical table, we could simply write an expression like create table name as TBL customer country. Alternatively, we could create a view as well. So rather than create table, so the moment you create table, this becomes physical data modeling. When you create a view, this becomes logical data modeling. So I call create view and view name, right? Let's create this view. Okay, I got duplicate members. The view is already exist. What we do, we give some different name. Give a name called version 1, and I create a view. A view got created, right? Now you see over here, once the view got created, I would delete these two table and rather I would use a view. So I'm not going to physically delete them. I would like to keep it over here for now, just for the sake of testing, right? So what I do, I'll run my metadata wizard once again and pull my view over here. So pretty much I select data source and I select my schema. The last time I used asset schema from Oracle, and I select only views which exist in my asset schema. So this is called VW customer country, which you see at the bottom, customer country. Just pull this into your framework manager. I'm going to use pretty much the relationship as primary key and foreign key. So that's done. Now I'm going to define a joining explicitly between your fact table and your dimension. So select both, right click and create relationship. The joining criteria is from dimension to fact is always one to many. So they join based on customer ID. Right? If you're not sure about it, the one solution, you go back and read your metadata document, metadata dictionary. Alternatively, you can double click over here in this example and see how do they join to each other based on country ID, and how your customer in turn join to your sales. If you look over here, they join based on customer ID, right? So now rather than using two physical table, I use a view. Now the important point over here to pay attention, we should check the data. The data should be remain same if I use view or table. Now this is a point to note it over here, to be noted. I'm choosing region, country region and amount sold, and I test this. Any discrepancy required to be investigated. I click on test, I apply auto sum and look at the data. So I'm going to apply test at two levels. First I'll test the data, and second I test a query. It's a good idea to test so that you can find any discrepancy which might exist. So you see when I process this, the number of records are 5 and the query being used. I can also capture the query, go to the query section, copy this query and put into your, I'm putting into a PLSQL editor, which makes my understanding easy. I can easily understand the query. So right click and paste. Right, I use the option beautifier over here, which make my understanding easy. So you see my view VW customer country joins with sales, and the criteria of joining is customer ID. So this is your query, and you got a view as well. So output and query both. So I'll just smaller the size of the font so that I can accommodate my query over here, right? So the area where we should draw attention is your customer joins with country. Customer, your view customer join with sales. Let me correct, customer join with sales, right? Now let's reprocess the same query without using view, and we test the data. So I select country name, customer, region and amount sold, right click and test. Something might surprise you if data is different. So now the number of rows are 6. Oh, it will remain 5. Let's test this. We compare the output. Okay, so my output, my query remains same. Sorry, my output remains same. We'll check the query as well. So number of rows are exactly same, and the data value we can also test. Right? Now what I'm going to do, I'll also check the query. Take this query, and this time my query does not use view, rather than the query is being processed by taking your denormalize model. I'm going to simplify this model, beautify this, select the entire query and beautify this. Right? So solution 1 where I use views, solution 2 where I did not use view, directly use the model as it is. Now let's use the third solution. So quickly recapitulate over here. So what I did, how did I denormalize solution 1? I use views which I bought from physical data source. Second solution, I'm going to use which stitch these two dimension into a single dimension. So I'm going to denormalize in the framework manager itself. So what I'm going to do, I right click over here, I keep them as it is, let it be here, which may require for testing purpose, and right click, create new query subject. Right? In a query subject, I would give some name and make a note over here. My query subject would be source from my physical data source, and I call this PDM customer, country and customer. My country is my driving dimension, country and customer. Right? So I would choose all the dimension and facts I need, all the dimension members. So I would select whatever dimension member I need from country and customer. I pick up all. For the sake of simplicity, I'm keeping only 3 columns: customer and countries, country region, sub-region, country ID and region ID. So whatever column you need, you select and drag and drop. Right? So country ID is a common column on which they are going to join. From customer, I ensure that I have taken all the foreign keys. Otherwise, joining may not be feasible, may not be possible. So they join on country ID. Right. When you go to next, your Cognos identify suggests you what could be the joining criteria. By default, it reads a common column name or the relationship based on primary key and foreign key. So this suggestion is good. I find this is the right suggestion. Both of them are joining based on country ID. Country and customer are joining based on country ID. I can go next, and hence your query ready. So now my source is, I denormalized both dimension and created one source and named it as physical data model country customer. Then I join them. It's not exactly a physical data model, it's just a way to recognize it. Sorry, that's not correct way. By mistakenly I create a shortcut of it. So I would create both of them and right click and create a relationship. So they join based on customer ID, where my fact is always many side of cardinality and dimension is 1. Right? So I join them at my framework manager layer. It is suggested all kind of data model simplicity should be done at your business model mapping layer. The physical model should not be used often to simplify your model. All business rule, complexities, filters should be modified done at your physical in your business model mapping layer. But in this example, because I'm stitching these two dimensions at your physical layer, therefore it was mandatory. We'll see the alternate option as well. So I write the same query again and test the data. So I select country, region and amount sold, right click and test. So we compare all 3 output and the query as well. So my third output is also same as first one and second one. I cut the piece over here and I compare. So you see the first output was by using views, database view, and second one by denormalizing at your framework manager layer. So you got 2 methods and you see pretty much the output is remain same. Okay, now let's do this approach, third method. The third solution is you can simplify this model in your business model mapping layer or business model layer. So I create a pretty much business model where I'm going to join my customer and country together. So go to your business model and right click and create a new query subject. Right click, create a query subject. I call this country and customer. And this time I use the option number first called model query. So as you know, in business model we simplify all the complexity which I don't want to show it to my user. So I would select my country and customer. I'll choose all the required column from country and customer. So I select customer first name, last name. This is all I need. I don't have to worry about how they join because all complexities join level is addressed at your physical model. This is not correctly done. Let's do it again. So without worrying about how joins are taken place, what is primary key and foreign key, I can simply drag and drop. My query model will sit on top of existing query model. I call country and customer, and I drag and drop the required column. So from country I take region, sub-region name, and from customer I need only customer first name and last name. Right? Done. Now we are going to apply the same test. We use country, region and amount sold, and I'm going to apply the test, same test, and we compare the output and query as well. My output is same. We're supposed to capture the query as well. So my output remains same. Let's copy this and keep it over here so that we can check all possible ways of denormalizing it. So this we denormalize at business model layer. Basically you create a denormalized anything you do in business model is like creating a view, right? And you hide the complexity. This is done over here. Now we quickly test the query. You can test the query as well. This is your query. So pretty much the same query as we created as it got generated by using whatever we tested in physical layer. The query remains same. So I would quick test. I'll put all the query together and we can test, apply one by one. So this query which I applied at a business model mapping layer, this is my first query. Right click and paste over here, and I beautify to understand. In this query your country and customers are joining, and country join to customer and customer in turn join to sales. Right? Country join to customer and customer join to sales. The three level of joining. Whereas when I use views in your physical layer, we'll compare all these three queries. Now when I create a view and my query was same, I wanted region, country region and amount sold. Right click and test. Oh, I think I selected wrong. Country region and amount sold. Apply test on these two columns only. And this time you see my query, first query and second query is same. Copy and you keep over here. So first at your business model, second one by stitching these two queried physical layer. So in this example we use view. In the previous example I was joining country join to customer and customer join to your sales fact. Here rather than joining them, we create a logical view over here, VW customer country, which ease people understanding. View will hide the complexity. And third method where we did not create view, we stitch these two query, join these two dimension to a single dimension at your physical layer, test the data, and finally look at your query. Now this query, this is important to pay attention over here. Every time you join queries, you join dimension in your physical layer, this is being interpreted with your with clause. Why the with clause is being used? With clause is a substitute to your nested query, and by using with clause, we basically database use a temporary table internally, and the query performance is faster. So the difference which you can see over here, when I join these two dimensions at my physical layer, Cognos understand and interpret them with using with clause, right? So if you pay attention to this with clause, you see your query is being used and it has given an alias name. A query is used where country joined to customer is one part of the query. So first you denormalize them, country and customer, denormalize, join them, and given an alias name called PDM customer country. Then this alias in turn joined with your fact table. This alias in turn joined with your fact table. So this kind of query required to be used, A joined to B and B joined to C. So first I join A to B and AB to C. So Cognos understand this model by using where clause, which converts the entire query. First step, it creates a template table, then this template table in turn joined with another table. So this is how Cognos understand, and this is the various 3 different methods we learn through which you can denormalize the model. So with this, I'm going to stop today's session, and thanks for joining today's session. In order to see more videos, kindly log into our site www.bisptrainings.com. Thank you.